Hello, we're group two, and we are modeling a desalination plant and doing a cost analysis of this proposed plant. I'm Sophia Van Gelder.
I'm Nicole Norwine. So the responsibilities of this project is I will be explaining what desalination is, which is the process of taking salt from salt water and turning it into fresh water for drinking or potable use. So the responsibilities of this project, other than that, is Sophia will be going over the Aspen portion as she has done the Aspen portion of this project. I'll be going over the cost analysis in Excel as that was the portion of the project that I was primarily doing. We both researched throughout this process for both the Aspen and economical analysis. We'll both be presenting our findings.
So, the objective of this experiment was to model a desalination plant based off of desalination plants that are already in use today and to obtain fresh drinking water and also to do an economic analysis of the proposed plant design. Our scope is to use the Aspen to model the plant through researching different aspects of the current plants, like I had said, and to generate how much fresh water is being produced as the product. Then we were going to use the data from Aspen and outside research to determine if the process is economically feasible, which would be done by doing a cost analysis in Excel. And if it is feasible, we wanted to know by how much.
So a quick overview of how we had done this process and project. We first researched desalination plant components and properties such as the machinery and the general how it works. We assembled the plant on Aspen. We inputted streams and block specifications from our findings. We had done that twice as we had two drafts of the desalination plant. The second draft worked better. We ran the simulation and obtained results, and then we started research for the cost associated with the project to start the economic analysis. We began the economic analysis without using the data retrieved from Aspen. We implemented the Aspen results to complete the remaining costs and then ran the economic analysis, which then let us form a conclusion on if this process is economically feasible and worth building.
So I'll begin talking about the Aspen portion of the project. We created this flow sheet, like Nicole said. This is our second run, which we included a pump, a heater, three membrane filters, and then a mixer for the brine streams, a distillation column, and then finally a cooler to cool the product stream coming out. First, we started by figuring out what components we needed in the salt water, which is obviously water and salt. And then we included the next most common component, which is actually magnesium chloride that is present in ocean water. And we needed to figure out the mole fractions for how much of each component is actually in the salt water. And we got this data, as you can see on the left, from a couple different articles we researched. And then we just divided these, how much is present, by their molar mass to get the amount of moles. And then we designed the process to run 100,000 kilomoles per hour of the seawater into the plant. Here you can see the pump setup and the heater setup, which the pump we had increased from ambient temperature or ambient pressure to 20 bar, so it can pump the seawater from the actual ocean to the process and through the process. The heater we had heating up from ambient temperature to 30 degrees Celsius. So it would work better. The reverse osmosis would work better in the membrane filters. Next is the membrane filter setup. We knew through research how much salt and the magnesium chloride would be coming out with the brine stream, due to that just being the common ratio that's achievable through reverse osmosis. but we needed to figure out how much water was going to be coming out with each brine stream as well. We knew that after the three filters, that about 42% of the water from the salt water would be recovered. So we figured out about 25% of the water would need to come out with the brine stream as well, as you can see on the left hand side. And then we input that into Aspen, as you can see on the right hand side. This is the distillation column setup and the cooler setup. We had about 0.01% of the salt and the magnesium chloride remaining in the distillate, in the product distillate, and 70% of the water also remaining in the distillate product, with the rest becoming waste. And then the cooler, we had the product from the distillation column as well as the product from the third filter going to a cooler, which would now cool the water back to ambient temperature and pressure. So these are the stream results we achieved. The highlighted column is going to be our final product stream. And so, like I mentioned earlier, we had 100,000 kilomoles per hour of seawater coming in, and we were able to produce uh, eight, pretty much 82,000 kilomoles per hour of fresh water leaving our plant. We also we were able to obtain the plant utility costs through Aspen. To do this, we used the pump, the heater, and the cooler. The pump used electricity, the heater used steam, and the cooler used cooling air because we found that these were the cheapest combinations. And we found a total utility cost to be about $208 per hour, which we could then scale up to the cost per year.
Let's talk about the economic analysis done through Excel. So first, we're going to look at our initial investment, the land and building cost, and of course the capital cost or working cost. Working capital, which will be included in what you see in year zero. So our initial investment was about $2.75 million. Our land and building cost would be about $244,000. And our working capital, when calculated at the end of the first year, was about $800,000, which is our assets minus our liabilities. So then our cumulative cash flow for that year was negative $3.8 million. And as you can see, as the years go up, including inflation and the interest rate of the loan, we are seeing negative numbers as the plant operates further and further. In our cost analysis, it was found that the payback period time and the discount rate of return make this an unfeasible process economically. So on the cumulative and discounted cash flow rate, you can see on the cumulative cash flow, which is these darker blue, that keeps going down and down and down. This is our discounted cash flow rate, which does not show the payback period. The cumulative cash flow rate does, and as you can see, it is a non-achievable payback period, as it is more than 60 years.
So for the software and numerical methods used, the software we used Aspen and Excel. And for the numerical methods used in Aspen, we created a flow sheet, which, as mentioned earlier, included a pump, a heater, three membrane filters, which were two outlet separator. We used a mixer, a distillation column, and a cooler, which was really a heater ran in reverse. We also input data and specifications for the inlet seawater and each design block, and we utilized the Aspen Utilities tab for the pump, heater, and cooler.
In Excel, we broke down the cost of the plant design based off of peer-reviewed literature. We analyzed yearly cash flow with interest applied, and then we calculated the rate of payback period and discount rate of return.
The new concepts and tools we used for this project was using a different type of separator than what was previously used in class. We also implemented a distillation column into our process, which we didn't really do in class. We used a cooler, which was pretty much like I mentioned earlier, a heater that was ran in reverse, because that was the best way we found to implement a cooler. And then we also generated the utility costs via Aspen, which we had never done before as well.
So in conclusion, we were able to build a desalination plant in Aspen and retrieve the product output as well as the utility needs and cost, which then was done with an economic analysis, which found the proposed project is not economically feasible as it goes more and more into debt as the years go on as it operates, and there's no break even or payback period reasonable to implement this design.
So, what did we learn doing this project? Well, we learned how to use Aspen to retrieve utility costs. We also learned how to design a distillation column in Aspen. We learned what all the components needed to create freshwater from saltwater, which is the desalination plant. We also learned that utilities and employment costs are the most costly part of the desalination plant each year, not including obviously the initial costs to build the plant. And then not all plant designs are economically feasible, unfortunately.
These are our references. Thank you.
Thank you.